My name is Anord Gilbert. I'm a first year student at Mkwawa University College of Education. I'm pursuing a Bachelor of Science with Education, specialized in mathematics and economics. Okay, we are here to present our project titled as Application of Homogeneous Differential Equation and Integrating Factors in Daily Life. I'm with my fellow who is Anesius Andronicus and Joseph Onesimo. So now we are starting with introduction of homogeneous differential equation and integrating factors. So welcome my friend to continue with an introduction of our project.
Now, before looking for application of homogeneous differential equation and integrating factor, let's see the meaning of homogeneous differential equation. Homogeneous differential equation is an equation with its variable in the form of y over x. Mostly we solve this equation by using substitution of y is equal to ux, where u is equal to y over x. But in case of integrating factor, this is a mathematical method using to solve a linear differential equation. Let's consider the equation in the form of dy dx plus p of x times y is equal to q of x. This form of equation cannot be solved directly, but we need to use integrating factor. And integrating factor is mostly given by integrating factor is exponential function raised by our integral of p of x dx. Okay, thank you.
Now is an application of integrating factors differential equation in mixing problems such as salt mixed in water. Mixing problems involve in three things, which first, the amount of water entering into the bottle, and second, the amount of water leaving into the bottle, and the third is a substance that mixed into the water uniformly. So, by relating this into practical, I have a salt and a bottle of water. So, by mixing a salt and water, then there is some water become replaced out the bottle. The aim of doing this practical is to get first the amount of water, the amount of salt at any time, and second, the concentration of salt in the bottle. According to this practical, we get the formula, which is the change of A to change of T equals to letting in minus letting out, where we can change this into a change of A into a change of A to change of T plus P of A equals to Q as a formula of integrating factors, where the P and Q is the part of letting in and letting out. So welcome my fellow to continue with an application of homogeneous differential equation.
Okay, we have already finished with the application of integrating factor. Let me continue with the application of homogeneous differential equation. The homogeneous differential equation might be applicable in the spread of diseases, especially in the epidemic diseases. What are epidemic diseases? These are diseases that affect a large number of people in a particular area at a short period of time. I might give some examples of epidemic diseases that are like cholera, malaria, and COVID-19. All these are examples of epidemic diseases. Then, if infection rates depend on the ratio between the infected people and time, it can be mathematically shown as the rate of change of infected over the rate of change of time, which is equal to the function of infected people over time. considers a homogeneous diseases model, which can be written as the rate of change of infected people over rate of change of time equals to 1 plus infected people over time. Whereas in our model, 1 represents the basic constant of the increase in infection, and I over T represents the relationship between the infected people and time. Whereas when I over T becomes larger, also the spread of disease becomes so fast. Okay, now let me show you how to solve our homogeneous diseases model so as to get the number of infected people at a given period of time. We can solve this homogeneous diseases model by using the homogeneous means, such that by substituting, let me use a substitution of I equals to UT. Then we can differentiate and integrate to get our final equation. Let me take an example so as to make you understand this. Let's suppose an epidemic disease starts at a village. In day 1, there were 10 infected people. And in day 2, there were 20 infected people. In day 10, there were 500 infected people. This shows how infected people interact more with the uninfected people. Then they create new infections. This symbolizes that epidemic diseases always start slowly, then they accelerate. Okay, this is the application of homogeneous differential equation. Thank you for watching.